And that was a really small probability, right? Let me ask you this while we're talking about these left-handed people. Let's say I had 80 people. 11% of all Americans are left-handed. How many would you expect out of 80? Expect out of 80 to be left-handed. What's your best guess for that? Base it on math. Don't just go, I feel the number 7 coming. Maybe they'll show. Number 7. Does number 7 mean anybody? No. What do you do? If 11% of everybody is left-handed, then 11% of 80 is what I would expect. I keep saying that word expect like that. So what do you get? What's 11% of 80, which is 0.11 times 80? 8.8. So I would set up, around maybe 10 to cover my ass in case more come up, right? So one thing we don't have yet. Do you see what I just did? I just made too big of an assumption, but it still was better than nothing. I expect about 8.8. Now, why is that okay for the average to be 8.8? There's no 0.8 people because it's a freaking average. And we have to divide to get it so we can get decimals. So to be conservative, I rounded it up to 10. But what should I really know to get a good feel for how much I should go up so I can have enough chairs in case too many people show up? Standard deviation, 11. Oh shit. So every time we have a new way to have data given to us, when they had XP of X, we came up with new formulas for the mean and the standard deviation. Now we have NPQ problems is what I call them. Makes kind of sense. We have a total number, a probability of success, and a probability of failure. So I call them NPQ problems. So this is the best average formula we've ever seen. Because what do we do to get this? What is 80? What letter do I put there? N. N. And what's 0.11? P. So the mean is NP. Oh my God. That kicks so much ass. So I always, let me stop. Let me give you another example real quick. It's getting to the point where less and less people probably, enough of you guys know Shaquille O'Neal, right? All right, he used to be on the Lakers, poor guy, and then he was on the Celtics for a while. It's really tripped me out. I'm a Celtics fan, so let's say Shaquille O'Neal made 30% of his free throws, right? So we'll be generous. And he takes 20 free throws. He makes 30% of his free throws, and he takes 20 free throws. How many would you expect him to make? 6 of them. 30% of 20. N times P. So anytime you have this kind of a situation, this is called a binomial distribution. Why didn't we call it a binomial distribution? 2 options. I love it. Before we had left and not left-handed. Now we were just talking about making it and not making a shot. There's always 2. You can take any situation and make it 2, really. I'm playing Yahtzee. I need a 5, so I can get a 5 or not a 5. There you go. I like it. So then you can define what P and Q are, and you can attack it the way we just did earlier. And I might as well tell you, by the way, the standard deviation is the square root of N times, Jeff, you could do it, N times P times Q. Now just think back to sum of x squared P of x, and then you throw it into a formula. You got to add them all up. Or how about x minus the mean squared divided by n minus 1? And oh my God, those were kind of intensive and gross. This is absolutely beautiful. If you let it be. So for this problem right here, the average was 8.8. Can somebody calculate what the standard deviation would be for 80 people coming, for the standard deviation for the number of left-handed people I have coming? Oh, good. I have one person working on this. So N times P is 8.8 times Q. So is that what you got? 2.799. So I can kind of, just to make an estimate, I would round it up to 9, round it up to 3. So how many chairs do you think I'd get to be on the safe side? Yeah, in fact, what we do, let me stop there for a second. Is everybody decent with that? Now, I'm not going to go into the math behind this because it gets a little intensive. But the math behind this actually is way too easy to even believe. You do the percentage times the total number. It only makes sense. So these are the best 2 formulas we've seen yet this whole semester for finding the mean and the standard deviation. Some of you guys look like you don't agree with me, but you should. Bless you. So here's an idea about unusual. Where does unusual start? And for most things, it starts, let's see, so for empirical rule, oh shit, this is something you're supposed to know. Empirical rule, if I go out 1 standard deviation, how much of the data would I catch in there? 68%, 11. If I go out 1 more standard deviation, how much data would I have caught between those 2 things, within 2 steps? 95%. So how much is outside of 2 steps away? How much is outside then? 95% in here, how much is outside? 5%. And if something had a 5% chance of happening, would it be unusual if it happened? Yes. If you had a 5% chance of seeing a seagull steal the hat off of somebody riding a Harley Davidson motorcycle. I don't know why I'm stuck on Harley Davidson, right? That would be, you would go, oh my God, what did I just see? Why was I not taping? Shit. Right? I mean, that would be really unusual. So we officially call unusual to be 2 steps, outside of 2 steps from the mean. So the mean minus 2 steps, and the mean plus 2 steps. So that's where unusual starts. Everything inside there we would call usual, expected. We would expect it to be somewhere in there. Anything outside of there is unusual. If that happens, we go, what the hell? It's just like seeing somebody who's 8 foot tall. You are going to take a double take. You do not see that all the time, or at least I don't. Maybe some of you do. I sure don't. So what is the maximum number of usual left-handed? How many would you expect left-handers? The most you would expect to see come? Yeah, it would be the mean plus 2 standard deviations. So if I go 2 standard deviations up from the mean, that's going to be the highest usual amount that I would expect to come. And what'd you get for that? Uh-oh. You guys have calculators there, right? You can use them, right? $14.398, so like 14.4, let's say. So if I got 14 chairs, I'd feel pretty good that I would have enough. It would be unusual if more than that showed up. If 15 left-handers showed up, would that be unusual? If 15 left-handers showed up, would that be unusual? Yes, because that's outside of what I expect. Let that be nice. That totally jives with what we know the word unusual to mean. So mathematically, it means the same thing. It's something you don't see very often. It's outside of the realm of what you expect to happen. It's exactly what unusual means here. All right. Let's see. Let's do one more quick example, and then I'm going to let you guys work on a handout. So let's say I talked to 68 people, and I know that the probability that somebody, let's do it like this, probability someone likes, I don't know, broccoli is, let's say, 0.37. It's probably higher than that. I don't know why I'm just broccoli. Oh well. And now I want to know the probability, if I have 68 people, what's the probability that I get exactly, what you got, Jeff? I don't know. Show me what you got. Exactly 25 liking broccoli. So what do you want to identify for yourself? You've got to identify what N is, what P is, and what Q is. And the last thing I haven't told you yet is we call this number, the number of successes, we call that X. Because that's the true variable. That's the number that can change. This number can't change. That's the percentage of everybody who likes broccoli. Just because you take 20 people, they don't change that, and you suddenly, I don't like broccoli all of a sudden. No. This is the number that can change. Exactly 25 like it. Exactly 26. Exactly 11. I can change that number. The other ones I can't. So we call that one X. So what's N? 68. What's P? 0.37, because I'm looking for people that like broccoli. And what's Q? 0.63. Kick ass. Because these, of course, what's always got to be true about P plus Q, that has to make 1, because they're opposites of each other. They have to fill each other in. So what's this formula going to look like? How many people do I got? I got 68, and I want to choose how many? 25 of them to like broccoli, right? 68 people, I want to choose 25 of them to do something that I'm going to call a success. So this is kind of repetitive, but that's kind of nice. So how many of these do you want? How many of these do you want? What is that? That's probably somebody likes broccoli. How many of those people do you want? 25. And how many of these do you want then? If 25 of them like broccoli, and there's 68 total people, how many of them don't like broccoli? The rest, 43. So let's see what that looks like. Again, this is 25 successes. This is the rest are failures. And this is how long the list would be if I wrote it out. Thank God we don't have to do that. So I got that. I don't know what you guys got. You get close? You get the same thing? Makes you feel okay. So I get 9.985% chance. All right. So what I want you guys to do, you can work alone or together if you want to. Either way, on this handout.
Wait, wait. I'm not really fine. So don't say the word that word now.